Okay, in our previous video we have implemented a method to check if a given linker list is empty or not. Like that means we already implemented this we implemented this function, this is empty function. So, and we tested this implementation from our test program, which is here. Like we tested, we declared an empty list, initialized an empty list here. Then we check that like this. And then when we first we compiled it, then when we run it, like the list that we created is empty, and this is empty is true. So we are already done with that, with our is empty implementation. The next task will be, like in this video we'll work on the implementation of two methods. The first method is implementing a method to add a node to the head of our linker list, and the second method will be implementation for adding a node to the tail of our linker list. So let's open our linker list implementation, which is our single linker list implementation, which is this class. Then let's add those two methods. Okay, let's here implement implementation of adding a node to the head of the list. Then while doing this, the steps are, this includes adding a node on the first one is adding a node to an empty linker list, and the second one is adding a node to non-empty linker list. In both cases we are creating a node. In both of the above cases we are creating a node with s next set to null. Let's do this. Okay, public, and this method will have no return type, and a certain type is set to null. That means this method is not returning anything. Like, well, actually we can set its certain type to boolean, so that if the node is successfully added, it will turn true, otherwise it will turn false. That's not necessary. Let's just give the method name, which is add to head, and the info that we are going to set, we are going to add is the integer will be set to info. Let's pass that as a parameter, and let's create our node. Okay, this node will be this will create a node with its next set to null. Okay, creating a node with its next set to null. Okay, then now let's check if the adding a node to a non-empty list. In this case, if the is if the list is not empty, then we are going to do this. If the list is not empty, let's set the next of this newly created node to the current head, which is node.next will be this dot head. Then we'll update this newly created node to the current node. The current node will be updated by this, will be set to this newly created node. Thus this dot head will be the newly created node. Okay, otherwise adding a node to an empty list, this means if the list is empty, the newly created node will become both the head and tail of the list. As will be like this dot head equals to this dot will be equal to this dot tail, and this will be the newly created node. Okay, this will be set to this node. Now let's now we are done with this implementation, our third implementation, and let's test it from our test class, test program. Let's open this, and now let's start working on this one. Checking adding to the head of the head of the list, adding a node to the head of the list. Then let's come here, down here, and add, okay, adding a node with info 5 to the head of the linked list. Okay, let's linked list, then add to head, then 5. Okay, this is it. Okay, let's check. First we created an empty list, and when we check if it's empty or not, this returned true. That means our list was empty. Now let's check once again if this list is empty after we added this node to the head of our list. Let's do that. We can do that using the same why, like, is our list are still empty? Okay, is empty. Okay, let's comment this. Checking. Okay, if the list is still empty, now let's check this. Let's compile it using our compiler, which is Java. Okay, let's run it. Okay, first for the first case it's returning true. Then once we added our list, okay, is our list still empty? It's set to null. That means once we added to the head of our list, the list is not considered as empty anymore. So it's working. Now let's do the same for adding to the adding a node to the tail of our linked list. Okay, let's do this. Adding a node to the tail of the list. Then this includes adding a node to okay, to an empty linked list. Then second one to non-empty linked list, similar to adding a node to the head of. In both cases, both the above case, we are creating a node with its next set to null. Then we will update the tail to using to this newly created node. Okay, here we are updating the head, right? Then we will update the head to this newly created node. Okay, let's make it the same. Then okay, let's similar to the similar to adding to head. This now we are not required to return anything in this method as well. So the method is set to add to tail. Then we'll accept this info. Then let's create with its next say to null. Okay, then new node, and we'll force the info. This will create a node with a set its next set to null. Then let's first add adding a node to the tail of an non-empty list. Okay, if the list is not empty, let's check that. If the list is not empty, then this dot tail dot next will be set to the newly created node. The next of the current tail will be set to the newly created node. Then the tail will be updated to this this new node. So this new node, the next of the current tail will be updated to the newly created node, and the current tail will be updated by this. First we are attaching the newly created node to the existing list. Then we are updating the current tail to this newly created node. Then otherwise a node to the tail of an empty list means, like, if the list is empty, that's where that means we are setting both the head and the tail to this newly created node. That's just simple, pretty simple. Okay, let's test this one. Okay, let's test this one from here, which is our sub test will be okay. checking adding a node to the tail of the list. Then let's do that here. Let's do this to add to tail. Instead of our tail, let's add a node to the tail, add a node with info5 to the tail of the linked list. And where we created an empty linked list here, then we check that and it returns true. Then we are adding one node to the tail of our linked list. Again, let's check if our list is still empty. If this return false, that means we are correct. If this return this the last print statement, if this print true, that means our implementation is incorrect. Okay, let's do that. Let's compile it again. Then let's execute this. So this is still working. This is still working. That means we created an empty linked list and we check that using this one. We check that using this one, and that returned true. This returned true. Then then we added to the tail of the list. Then we again check is the list is still empty, and this returned false. That means our implementation is correct. In the next video, we'll see the actual list by printing the whole list, and that means our next implementation will be like printing the whole list and searching if a given element exists in the list or not. We'll again implement two methods. Like the first method will print the whole list, and the second method, so that we can see the node, the head and stuff. We'll print the whole list from the head to tail. Then we'll continue working like that. Then we'll implement another method which can check if a given node exists in the list or not. That's it. And thank you for your attention. I hope you enjoyed this one as well.